Yes, so as Florida mentioned, I'm Tracy Lum. I'm a developer at the Flatiron School, and I write mostly in JavaScript and Ruby, but lately also Elixir. I'm also a 2015 graduate of the program, and apparently I liked it so much that I just stayed. But anyway, every day I get to work on a magical platform called Learn.co. And Learn is primarily a learning management system, but it's also so much more. So in addition to our primary learning or a lesson page, we also have cool features like a career services portal, study groups, a magazine with blogging built right into the platform, and our new ID in the browser, which we will get back to. But as amazing as Learn is, and as much as I love working on it, it's also a few years old, which brings me to legacy code. So, in contrast to what Barney Stinson might suggest, new isn't always better, old isn't always bad, and old code bases aren't always necessarily legacy code bases. So before we get too deep into legacy code bases, I wanted to talk a little bit about some common definitions. So this is the most widely accepted answer on Stack Overflow. It mentions technologies or systems that are no longer supported or have been superseded. It also talks about letting those systems die, which is really a great way to kick off our afternoon. Recently I've been reading Working Effectively with Legacy Code by Michael C. Feathers. It's a book I highly recommend, but to begin the book, he writes that the definition of legacy code is code that we've gotten from someone else. So any code that you didn't write, you might consider legacy code. He then goes on to refine that definition, and he writes that, to me, legacy code is simply code without tests, which makes sense because code without tests is hard to change safely. Like you might change something, but you also might break something somewhere else. So super hard to change, and that too might be legacy code. And after reading this book, I started wondering, am I actually working with a legacy code base? So, does it include technologies that are no longer supported? Definitely. We have a lot of old stuff hanging out, including stuff like Sales.js and Alt.js, which hasn't been updated since 2016. Really exciting. Was it inherited from someone else? So I am definitely responsible for writing a lot of the code inside of Learn, but a lot of it predates me, like before I was even a programmer. So for the most part, yeah, it's inherited from someone else. The next question is, are there tests? So, wouldn't you know it, we have some tests, but we are definitely far from 100% test coverage. So there are certain parts of the app that are harder to work with than others. So yeah, with all these check marks, I am definitely working with some sort of legacy code base. Yeah, and that's fun. So next up, as I mentioned earlier, I've been reading that book, Working Effectively with Legacy Code, and in that book, Michael C. Feathers encourages developers to tell the story of a code base. And that story is important because without the context and without understanding why something is written, it's hard to know what's going on exactly. It's also easy to get really frustrated and angry at what you're seeing. So with that in mind, I want to take us on a little journey through a brief history of JavaScript in my code base. So in 2014 is when Learn was started, and at that point, no one was quite sure what it would eventually become. March 2014 is when someone on my team typed Rails new and created this cool new app. And at that time, our front end was primarily spaghetti jQuery, which is maybe some of you can relate to. Then we decided that we needed some kind of order in our code base, which is cool too. And you'll see that a lot of changes throughout our code base were in response to changes in the larger JavaScript community. So we are products of our times, and so is our code base. So in January 2015, we introduced Ember into our app, because Ember was gaining traction then, it was pretty popular, so Ember got added to the app. In May of 2015, we actually hired a developer who was more experienced in backbone Marionette. So he petitioned to add it to the code base, and that too was added to the code base. Later on, we realized that Ember wasn't quite meeting our needs, and we decided to instead add React to our code base. We use React and Alt.js, which is that state management library that hasn't been updated since late 2016. And at that point, we decided, okay, this is too many frameworks, we gotta get rid of one, so Ember, unfortunately, got removed. As I mentioned, Alt.js hasn't been updated recently, so when that no longer met our needs, we decided to add Redux, and that was about a year ago. So that brings us to today, where everything is just fine. It's kind of a lot to work with. Like, you have to go travel from different parts of the app. You have to context switch a lot. And the challenge for us as a team today is to try to make our code base better, because this is sort of our home. We spend a lot of our time there, and it's in our best interest to try to clean it up and make it better. Certainly, when I'm working with our code base, the temptation to burn it all to the ground and start over is strong. There are a lot of times when I'm coding with someone and I start to flip tables, which is also really exciting, but yeah, it's a lot to work with. So, with that in mind, with legacy JavaScript in mind, today I want to take us on a little journey to talk about practical strategies to move forward in your legacy code base. And I'll focus more on making strides, making like incremental improvements rather than paying down technical debt. And this is an outline of what we'll go over today. We'll talk about building bridges, we'll talk about looking for seams in your app, and we'll build up to doing a rewrite when the time is right. Okay, so first up, let's talk about building a bridge. So what you're looking at right here is a typical lesson page on Learn. It's got a title, it's got content, and it's got a bunch of other cool stuff on the right rail. Around this time last year is when we decided to build our IDE in the browser. The only thing is, we need to make many systems communicate. So first up, this is the lesson page. What you're looking at is primarily Backbone and Marionette that was written in 2016 when we did a whole overhaul of our front end. The only thing is, when we added React to our code base, we decided as a team that all apps going forward should be written in React. And this app certainly fit the bill. So the mocks that our designer showed, or came up with, looked more like this, where we have this cool IDE sitting on top of the lesson page. The only problem here is trying to make React and Redux talk to Backbone and Marionette at the same time. In order to do that, we decided to build a bridge. But before we build a bridge, we need to know a little bit about each side in order to make them to communicate. So this is going to be just enough Backbone and Marionette to get by for example. So I am definitely not a Backbone Marionette expert. This is like pretty much all I know. So in the Backbone Marionette, they use the Backbone radio as an event bus to communicate. So in that system, there are event emitters, and then there are event listeners. When you want to dispatch some kind of event, you would say like radio, you trigger this event with a name, send over some information, and then listeners throughout the app respond to that event. Cool. So this is an example of a Backbone model. A lot of stuff is going on here. It is really complicated, and I don't want to get into it. So we'll look at this pared down version here. So this is a curriculum model. It's specifically our lesson model. And in our show function that gets called as part of the lifecycle of this model, we see that we get a reference to a radio channel, and we trigger the show lesson event. Since this is a learning management system, you might expect that a lot of things are paying attention to that one lesson event. And it's actually really important. So there are listeners throughout the app that are saying, okay, when you get this event, I'm going to go respond the way I want to. And it's this event that drives a lot of the behavior on our app. Cool, so now we know this is a super important event that we don't want to miss. Moving on to Redux. This is just enough Redux to get by too. So in Redux, I find it a lot simpler, but anyway, there are actions that are just objects that consist of a key of type and then an optional payload. Those actions get sent through reducers, which are just functions. They change state in response to the actions. And then we have our Redux store that holds the global app state. It registers listeners and also has the API for dispatching actions. So that's just enough Redux for this whole bridge to work. And we look at our actual bridge, we call it the Redux radio proxy. And all it's doing here is it's a function that accepts an argument of the Redux store. It creates a reference to the global radio channel, and it sets up a listener for that Backbone event. So when we get that event, we convert it into a Redux action, and we go ahead and send it through our reducers. And in this way, we can make Backbone talk to Redux. just to zoom out for a second, that's what this looks like in diagram format. So we have Backbone, Marionette, and Backbone Radio hanging out in one part of the app, specifically that lesson page. We send out Backbone events. We convert those Backbone events into Redux. We send them through the Redux radio proxy to convert them into Redux actions, and those Redux actions get sent through Redux, which our React component subscribes to, and then state is updated, and we have an awesome IDE in the browser component. And this way, we're able to establish a nice bridge, and we're also able to insulate both libraries from each other while still having them talk together in a neat fashion. And this also establishes a nice flexible way for us to move forward if other apps need to communicate from the Backbone old stuff to the React and Redux new stuff. And certainly since then, this Redux radio proxy has grown a lot. However, this doesn't remove our reliance on Backbone and Marionette. It doesn't get us any closer to actually removing it from our code base. So that brings us to our next example of looking for a seam. So whenever we get the chance, we try to remove Backbone and Marionette from our code base. It's not always easy, but looking for the seam is kind of an adventure. And we've done this before, and this is one example of that. So again, we're looking at an example of lesson page on Learn, and all the stuff that's grayed out is in Backbone and Marionette. But this track nav component that we see is rendered on top of that, and it's rendered through React. And if we look at the code, we can see that the way that we accomplish this is pretty similar to probably things you've read on the internet, like blog posts of converting Backbone into React views. And that's pretty much what's happening here, where we have our track nav view that is actually a Backbone view. But instead of rendering a Backbone template, we instead put a React component in its place. We keep the Backbone models and all of their lifecycle events, but we take that model and we pass it into the React component as props. And instead of rendering, instead of rendering that Backbone template, we're replacing it with React. So that's cool. Really cool that we can make these two systems communicate together in this one file. But again, not any closer to removing Backbone from the system. So a good opportunity to explore another way to do this was when we had to introduce Jupyter Notebooks into Learn. This happened earlier this year, and what we're looking at is a Jupyter Notebook rendered through React, and it is, yeah, it's really cool. But anyway, there are some parts here where we encounter the same difficulties where we're still trying to make two old systems communicate together. So what I want to focus on here is actually that blue run test button. It looks small and innocuous, but a lot of stuff is actually happening there. Because when you click on that button, it becomes disabled while tests are running on a remote server. And this Jupyter Notebook leverages the same system that we use for our backend IDE. So there is a Phoenix server involved, it's communicating over WebSockets. Both those WebSockets are only really taking their messages and passing them through Redux. So the thing about this blue button is that we needed a way to be certain to re-enable that button when the tests were actually done. Now, when we first got this requirement, I was like, can we just cheat? Like, can we use a set timeout or something? But the product disagreed and said that wasn't cool, so couldn't do it. The idea is that if something along that complicated chain broke, it would be impossible to recover from it, so it would produce a pretty suboptimal user experience. So instead, we decided to actually do it for real. And while we were doing this, we were thinking this was another good opportunity to look for a seam where we could rewrite, or we could replace a Backbone Marionette component inside of our app with React and Redux. And because it was so small, because this blue button is just contained inside this toolbar app that's hanging out at the top of the page, it seemed like it would be a reasonable thing to do. So when we started looking at the code, that's what it seemed like. Like, it's pretty small. Surely it couldn't be that hard to replace this one app with React and Redux, right? Yeah, this is pretty standard. It has functions for which to start. It's paying attention to that show lesson event that I mentioned earlier, and it just renders the toolbar. Cool. However, when we looked closer, it's actually responsible for doing a lot more than we initially anticipated. And no matter how hard we kept looking for the seam, it wasn't quite working. So we time-boxed our efforts, and we decided it wasn't quite the right time to rewrite the whole thing. Yeah, unfortunately. So what did we decide to do? But make a reverse bridge. Now, we intentionally before only made it a one-way bridge with the idea that eventually we'd get closer to a rewrite, but here we ended up doing the reverse. So we really cleverly entitled our reverse proxy the radio redux proxy, which is super confusing, I know, but that is what we ended up with. So just to zoom out for a sec, this is what we're doing in the reverse direction. So we have our Phoenix backend. It's communicating over WebSockets to a Jupyter Notebook channel on our client. Those messages from over the WebSocket are getting piped into Redux. And those Redux actions are then passed through a middleware, which is where we inserted our radio Redux proxy. Middleware is where all the weird stuff happens in Redux, because usually you keep your reducers pure, and this is definitely a weird side effect, so we just stuck it in there. So we have a radio Redux proxy, and it converts those Redux actions into backbone radio events, and then we set up backbone listeners on the other side to re-enable the button. So if you think about this, this is the whole life cycle of that blue button. Click on it, WebSockets, messages are getting passed over the WebSocket, the button becomes disabled, and when this whole cycle of messages comes back, that blue button gets re-enabled. So it's quite a journey for that one thing to happen. Anyway, so if we look closer at our radio Redux proxy, which again is the reverse of what we did before, we have just a standard middleware. It accepts the store as an argument, and then it switches, or we have a switch statement set up so that different types of radio events are triggered when those different types of actions get sent through it. So you can see like when the Jupyter run test is done, we trigger this radio event, and that's what enables blue button again. So again, not ideal. We're looking for the seam, couldn't find it, and instead we bought ourselves some more time by building a reverse bridge. Cool. So now we're dealing with a pretty grotesque amalgam of code. We still have all of the libraries we started with hanging out in our code base, and now we just have ways to communicate between them. Lots of bridges are being written. But ideally, we would like to rewrite. And fortunately, that opportunity came up when we got this new requirement to build a pared down version of the lesson page for one of our partners. So it looks pretty much the same. It's, the big differences are that the colors are different. The toolbar app that we looked at before is now missing a lot of that, those extra buttons. The right rail is also much pared down. We don't see chat, we don't see study groups. And because we wanted to rewrite, we realized this was a great opportunity because the seam that we were hunting for before with the toolbar app is actually one level up at the lesson level. So this is perfect, like, this is great. And what I want to focus on during this rewrite section is specifically the lights. The lights are one of the most important parts of the Learn app. Our students love them. I remember when I was a student, I was pretty addicted to them, so it's one of the reasons I probably stuck around. But yeah, the lights app, it's really cool. And we ended up with code that looks like this. There's a lot of stuff going on in that lights app. They change color in response to your different types of submissions. So when you're trying to complete a lesson or something, they change color. And we were able to take a sprawling lights app and convert it into something that was a lot more elegant and a lot simpler, just because we knew of all the possible use cases here. So we have our lights container. It takes some props, and we send those things on the right-hand side, the assessments, and we turn them into lights in this way. So a neat component. If we look at another component, the light factory itself, we're using the strategy pattern to take props, turn them into components, and then just render them. So it's pretty nice. And through this rewrite, we were able to go from a sprawling background marionette app looked like this. There are so many files that actually bleed off the screen. I didn't bother formatting them because there's so many. And we turned that into something a lot smaller that looks like this, which is really exciting. Now, we didn't actually get to rewrite everything. We did the bare minimum to make this work as a proof of concept. But here we have a pretty nice pattern for moving forward if we did continue to rewrite the whole thing. The only thing is that we had to rewrite this in parallel because this is a production app. Students are accessing this every day. They're using our app and they're learning things, which is awesome. And we decided to rewrite this behind sort of like a dark code way by putting it behind a different path. The only thing was sometimes students would load that original Backbone Marionette app and they would end up with this crazy error that rendered the right rail pretty much unusable. And it's weird because it's referencing a lot of Redux stuff, even though it's rendering the backbone Marionette app. So super confusing. And a bunch of us decided to debug this because that is not great. And it ended up looking like this. I don't know. We spent a lot of time trying to figure out what was happening. And we went through the controllers, the serializers, the routes, traced it back to the front end. And man, it was just ridiculous. So we eventually isolated the bug. Turns out we expected our payload to look a little something like this, where we have our lesson info, it has a title, it has assessments. So again, those assessments are the things on the right rail that turn into lights. And for some reason, somewhere in the code, the assessments were actually being removed. I don't know, it was confusing. Like, where was this happening? We couldn't find it. But then finally, we traced it back to somewhere deep inside that backbone curriculum model. It turns out we were deliberately removing the assessments for some background reason that I'm not sure of. But we Git blamed it, and it turns out the person that was working with me at the time on this project was also the person responsible for writing it. And I asked her, like, what is this for? And she had no idea. So that was exciting. And we finally just went ahead and removed it. And then everything started working again. So hooray, that debugging session was super successful. Anyway, that brings us to the end of living with legacy code. Yeah, sometimes it can be hard to work with, sometimes it's difficult, but sometimes it's kind of fun because you get to exercise your best detective skills. Now, rewriting definitely isn't something that's all or nothing. You can definitely buy yourself some time by building bridges between libraries before you can eventually rewrite them. You can also look for the app seams. Sometimes it's easier to find than others. And then finally, when the time is right, you get to rewrite, which is awesome. The only problem is just look out for unforeseen bugs like the one we encountered. Yeah, that is pretty much it. Thanks for listening. Hopefully that was helpful. Hopefully you learned something. And yeah, you guys for hiring. So thanks.